You know, when you picture an asteroid hitting Earth, your mind probably jumps straight to a giant explosion, right? A blinding flash of light and then darkness. But what if the biggest danger isn't the impact itself, but a silent, invisible killer that comes after? All right, let's get into it.
We all know the classic story. About 66 million years ago, a rock the size of a mountain, 10 kilometers wide, came screaming out of the sky and slammed into what is now the Yucatan Peninsula. That gave us the Chicxulub crater and, well, the end of the dinosaurs. It's the ultimate cautionary tale from the cosmos.
I mean, sure, the blast, the mega tsunamis, the firestorms, that was all unimaginably bad. But what scientists are now realizing is that there might have been another killer on the loose, an atmospheric poison unleashed by the impact that went to work on the very shield that protects life on Earth.
So in this explainer, we're going to pull back the curtain on this hidden threat. We'll look at what happens when these things hit the ocean, the chemical weapons they can unleash, how they literally punch a hole in our sky, what that means for life down here, and, this is the big one, how often this might actually be happening.
Yeah, our whole mental picture of an asteroid impact is all about raw power, the shockwave, the crater, the dust and soot blocking out the sun, creating what's called an impact winter. And don't get me wrong, those things are absolutely catastrophic, no doubt about it.
And this is really the core question we're diving into. Scientists are starting to look beyond just the raw physics of the explosion and are now digging into the massive chemical changes an impact can set off, especially when it hits in just the right, or maybe the perfectly wrong place.
So, how does a chemical threat like this even get started? Well, while a massive dinosaur-level impact on land is thankfully pretty rare, smaller impacts are way more common. And since, over 70% of our planet is water, guess where most of them are going to land? Yep, the ocean.
And we're not talking about another 10-kilometer dinosaur killer here. The research shows that an asteroid that's just 260 to 300 meters across, think about the size of a really big skyscraper, that's all it takes to kick off a global atmospheric crisis if it hits the ocean.
So just picture this for a second. An object traveling at over 17 kilometers per second, that's more than 45 times the speed of sound, slams into the ocean. The energy released is so insane, it doesn't just make a splash, it flash vaporizes trillions of tons of seawater, creating this superheated plume of steam and salt that just rockets straight up, punching right through the clouds and into the calm, dry stratosphere.
And you've got to understand, this plume isn't just harmless water vapor. Oh no. It's basically an atmospheric weapon, carrying a payload of super-reactive chemicals that it sucked up from the ocean and cooked up on its fiery trip down. And they are ready to cause some serious trouble up there.
Okay, so there are three main bad actors in this story. First, you get chlorine and bromine, which are basically ripped out of the vaporized sea salt. Second, the insane heat of the asteroid's entry creates a bunch of nitric oxides in the air. And third, you have the water vapor itself. That's a problem because the stratosphere is supposed to be bone dry, and all this moisture completely throws off its delicate chemical balance.
But here's the real kicker. While all these chemicals are bad news for the ozone layer, the research is pretty clear. It's the chlorine and its cousins from the sea salt that are the true villains. They are hyper-efficient at destroying ozone, way more effective than the other stuff. They're the real catalysts.
Okay, so we've got this poisonous cocktail of chemicals shot up into the stratosphere. How does that actually translate into punching a hole in our planet's shield?
All right, quick refresher, just in case. The ozone layer is basically Earth's sunscreen. It's this thin veil of gas way up there that soaks up the most dangerous UV radiation from the sun. Without it, life as we know it simply couldn't exist on the surface. And this is where the chemistry gets, well, terrifying. It's called a catalytic cycle. See, a single atom of chlorine, once it's set loose in the stratosphere, acts like a tiny molecular buzzsaw. It can tear apart an ozone molecule, then just move on to the next one, and the next, and the next, destroying up to 100,000 of them before it's finally taken out of commission. It's incredibly destructive.
And you know what's wild? This whole process is almost a perfect mirror of how we created the Antarctic ozone hole with man-made CFCs. In both cases, chlorine is the bad guy, and the destructive cycle is the same. An ocean impact is basically nature doing in an instant what it took us decades of pollution to accomplish.
So a hole's been punched in the sky. What does that actually mean for all the living things down below? Well, the effects start to cascade, and it gets ugly fast.
First, you get a flood of this nasty UVB radiation hitting the surface. It damages DNA, which is terrible for plants, animals, and us. That would almost certainly lead to massive crop failures and the collapse of agriculture. But wait, it gets worse. It's a double whammy because this is happening at the same time as the classic impact winter, when all the dust and soot in the air is blocking sunlight and making everything cold. So you get this 1-2 punch of deadly radiation and freezing temperatures. It's a catastrophic shock to the entire global food web.
Okay, this all sounds like a truly terrible day for planet Earth. But the real question is, how likely is it? I mean, how often should we be worried about this kind of chemical attack from space?
And this is what's really crucial to wrap your head around. When you look at the numbers, you see that impacts from objects in that 140 to 300 meter range, the sweet spot for causing a major ozone event, they aren't these super rare, once-in-a-million-years things. We're talking about an average interval of every 30,000 to 100,000 years. Now, in human terms, that's a long time. But on a planetary timescale, that's actually pretty frequent.
Let's put some hard numbers to that. The modeling suggests that an impact big enough to create an ozone hole, like the one we saw over Antarctica, could happen, on average, about once every 35,000 years. And a much larger, globally devastating event, that could happen roughly every 90,000 years. So this isn't just some ancient threat that got the dinosaurs. It's a recurring risk that's baked into the life of our planet.
So it really leaves us with this big, unsettling question. All of our planetary defense efforts are focused on finding the giant civilization-ender asteroids. But maybe, just maybe, we've been overlooking a more frequent, and in some ways, a more sneaky threat. One that doesn't just hit us with fire and fury from below, but one that could silently unravel our planet's entire life support system from the top down.